Okay, so we're going to look at simultaneous equations, but these are simultaneous equations that are not linear. In other words, the variables, x and y in this case, don't only have the power of 1. We have ones with the power of 2 here. Now, if you know about circular graphs, you'll know that the top equation is actually an equation for a circle. So if I wrote this out like that is equal to 20, I get a graph of a circle. Now, if we did the other graph, and it's not written the way that you would normally write out an equation for a straight line, but Desmos will be fine with that. There you go. Now, the solution for the simultaneous of any simultaneous equations, if you plot them like this, will always be where they intersect the y-axis. So that means that the solution to this, whoops, let me just block that in place. The solution, we're cheating here. The solution to the problem should be that either when x is equal to 2, y is equal to 4, so that's this point here. Remember, the first coordinate is x, the second coordinate is y. Or when x is equal to 4, y is equal to 2. In other words, a simultaneous equation that is not linear could have more than one solution, in the same way as a quadratic equation could have more than one solution. So that's cheating, that's jumping to the end, but also noticing how it can work with graphs. So now we're going to look at the process of how you would do it without cheating, basically. We've got our solution to the problem here, so we know what we should be getting. Don't need to be quite that thick. So how do we do this? Well, the trick is to get the equation that is linear, which we should have, and rearrange it. So I'm going to rearrange the second equation, the linear equation, by taking away x from both sides. So I've got y is equal to 6 minus x. And now I have a value for y, which is 6 minus x. I can put that in place of where y is in this first equation. So if I say this is equation 1, this is equation 2, I'm going to put equation 2 into equation 1. So that would mean that I write the x squared, and then instead of writing y squared, I write 6 minus x squared, because that is y. This 6 minus x is what y is, and I'm writing it instead of y up here. So the great thing about this, and I write 20 equals 20, the great thing about this is I now have an equation with only one variable in it. So the thing that you're always trying to do with simultaneous equations is combine the two equations so as you end up with one equation that has one variable in it, or one unknown value in it. And then you have to solve it. Now, this is not a linear equation still, of course, because it didn't start with a linear equation. So we're going to solve it. We're first of all going to expand it all out and see what we can do with it. So x squared, imagine this is 6 minus x multiplied by 6 minus x. So you got the 6 multiplied by the 6. I might just draw that out. So it's, let's put that bit in. This stage you may want to be able to do in your head. You may be able to do in your head eventually, but let's just put it down there anyway. So we've got 6 times 6 is 36 minus x multiplied by 6, so minus 6x, plus, well, so we've got then minus x, hang on a second, oh yeah, and then, well, we've just got to multiply all the different values. We've got best times this 6 by that minus x, so again minus 6x, and then minus x times minus x is plus x squared, because the minuses cancel out. That's equal to 20. So let's now collect. Now, what we might have noticed now is that we have essentially the beginnings of a quadratic equation. So we've got an x squared here, an x squared here, so we're going to collect that, 2x squared. We have the x's, which is we can collect together as well. That makes minus 12x. Then we have 36, and we have 20 over the other side. If we minus 20 from both sides, we end up with plus 16. And then because we've minus 20 from both sides, on the right-hand side, we'd get 0. So we have a quadratic equation, and at the moment it's looking like a complicated quadratic equation because a, in other words, the amount of x squares is not 1. If it was 1, it'd be a little bit easier, but it's not 1, it's 2. But luckily we've got a little trick because they all can be divided by this number here. So I can divide the left and the right hand side by 2. When I divide the right hand side by 2 with 0, it stays as 0. So the left hand side, I divide that by 2 and I end up with that. You won't always be able to do that, but with it's the first question, they've let us off the hook a little bit, and you end up with this one here. So now we've got, we know we're going to have, we're going to factorize this to be able to solve it. So we're going to end up with this, and something plus or minus something here, plus or minus something here. The x's will multiply to give the x squared, so that's good. The thing on this side will multiply to give 8, but they're going to add together to give minus 6. Okay, so two numbers that multiply to give 8 and add to give minus 6, they have to be two minus numbers, because two minus numbers would, when multiplied, will produce a positive number, and when added will produce a negative number. So two numbers that multiply to give, add to give minus 6 times to give 8 would be negative 2 and negative 4. So we've got that x minus 2 minus multiplied by x minus 4 is equal to 0. Therefore, these three dots means therefore, either x minus 2 is equal to 0 or x minus 4 is equal to 0. Now, if x minus 2 is equal to 0, well, let's just slow down a moment. Why is this the case? It's because we have two things here multiplied by each other, which are equal to 0. And when you multiply them, they're equal to 0. The only way you can multiply one thing by another and have it equal to 0 is that either the first thing is equal to 0 or the second thing is equal to 0. And so either this equals 0 or this equals 0. And so that would mean either x is equal to 2 or x is equal to 4. Whoops. Yeah. So, and we know, and then we say, well, we know that, well, y is equal to 6 minus x, which in this case will be 6 minus 2, which would be 4. Or if x was 4, y would be equal to 6 minus 4, which would be equal to 2. So in the end, we have this pairing, x is equal to 2 and y is equal to 4, or x is equal to 4 and y is equal to 2, and that's what we have up here. So that is a brief video on how to do that.